Hello, ladies and gentlemen, and welcome to another IDEA StatiCa webinar. The topic or the name of the webinar is Get the Most Out of Connection Modeling. So obviously, we'll be treating steel connections today, and the main presenter or the star of today is Jan Kubicek, a product engineer from our office. Janko, would you greet?
Yeah, that's me. Yeah, hello everyone and welcome once again. And it's yours.
Okay, so Janko will start his show in a minute, and besides him, it's me, Adam, another product engineer from the same office. And we're running on a GoToWebinar platform, so you are all muted by default, but feel free to ask questions through the questions panel, or you can type them in and we will be answering them during the webinar, and then pick some and answer them loudly at the end of the webinar, at the Q&A section. So what's today's agenda? 3 points: how to design simple connections effectively, how to design complex connections in the best way with a nice example, and how to skip all of that by using BIMlink with a CAD software such as Tekla. All right. So before I give presenter to Jan, I have prepared one poll for you. So let's launch it. And the question I have for you is, how would you estimate your experience with IDEA StatiCa Connection application? So if you either feel that you're still a beginner, or you have already some experience being, let's say, intermediate user, or if you would describe yourself as a real expert, or if you're completely new to this software and you have never used it before. So a couple more seconds, I'll let you vote. And I can see that 80% of you have already voted. Okay, so let's close this and share the results with you. Okay. So now you could see that about almost a half of you would describe yourselves as an intermediate user. We've got a lot of beginners here and some experts and some newbies as well. That's a nice attendee overview. And once again, warm welcome to all of you, no matter your level of expertise. So I will hide this and continue with the presentation, and that is already Janko's part. So I'm switching presenter to him and he will tell you more.
Perfect. Thank you very much. Thanks, Adam. So I hope you can see my screen now. Is it so?
Yes.
Perfect.
I can hear, and also I would ask you to turn off the cam so we've got the screen bigger and see it completely. And that is perfect. Thanks.
Great. Thank you once more. And yeah, we can jump into it. I'm quite glad for these outcomes of our first survey, of our first poll, because I think for beginners and intermediate users, this webinar could be the most beneficial. And what's the first topic is this, creating a simple connection models. So how could the design process look like? It's quite straightforward. We just need to make some model, then do everything necessary for a successful calculation, and we can go very briefly through checking of the results. So one important information for you, I would like to mention all the buttons which you should never use in our applications just to be successful. Fortunately, we don't have such a buttons because you can't make mistakes which couldn't be fixable or which you couldn't somehow edit in the future. So nevertheless, you start with whatever type of cross sections, materials, or language of the application. You can always edit these settings in the future. Small note to this, maybe small drawback is in the design code you select in the beginning. So that's, for example, you start with the Eurocode design, and then further in the modeling process, that's the only one you can't change within the same project. But we have a very simple workaround also for this issue. So you will see in the next part of this presentation. And then here you can see correct order of the operations. So that's quite important part of modeling our analysis models. The process of modeling is based on somehow simulating the real assembly of the steel connections. This means that we try to respect the order in the real life of creating the connections. So we can't, for example, weld the plate which is not there yet. So the future plate can't be welded in the past. So it sounds maybe strange, but it has some logic in it. And talking of or speaking of manufacturing operations, you can find all these operations under this button in our connection app, and then you will see that this set of small icons, 19 of them, and these are divided into some different levels of complexity. These red lines, or the first and the fourth line of icons, we could name it as a basic or general operations, and these green icons in between, these are enhanced operations created of these basic ones. So the basic operations are combined somehow into the whole connection or operation template, and you can use it for more complex operations or workflows. And the last line is the special operations features. So it's, for example, for connecting timber members to a steel plate. And when we go on, what's quite great tool, great friend for us is our initial connection wizard. The window looks like this, and this is the place where the most of the modeling could be done instead of us, because with selecting the proper template just in the beginning of the whole workflow, we can save quite a lot of time. We will see in our demo. And what's necessary for successful calculation? Similar to other analysis applications, we need these three model elements to be there. So we can check it in our application under this list: members, load, effects, and operations. So if these three parts are filled, we are on a quite good way to be successful with calculations. So with the members, I mean all the beams and columns and diagonal bracings which we need to embed into one joint. and to set correctly all the restraints on these members. Then the load effects and something to be able to connect all these members together. So some connection components, we call them operations as mentioned previously. Then model types and position of forces. It's related to setting or correct setting of our members. So in parameters, we should select correct model type for every member and also put our loading into correct position. Speaking of forces, it's also related with the feature of equilibrium. And this is quite important for some cases, but both these topics, model types and equilibrium, it's quite a long discussion. It could be embedded into separate webinar or separate parts. So if you're already interested and don't want to wait until we prepare something specially for it, you will find everything related to these topics in our support center, and quite a comprehensive theory is presented there. And in case we have successfully built our model and loaded all the members, then after calculation we should check the results of the analysis. So the first one we should check is a stress and strain course along all the members or along all the plates related in one connection. But maybe even more important thing about connection app is its strength to somehow show us the real behavior of the connection, which means we can display the deformation of the connection. We can display also contact stresses between parts, so where the plates meet, then we could check, or where we expect it should be in contact, we can check it really is, and we can see the stresses in there. And also when we expect some bolt forces to be there, we can check exactly what values, and also graphically where is the maximum, where is the minimum. And we can move on to the first demonstration of the very simple connection. It's a beam to column connection through a bolted end plate. So this would be example of how to model the same connection, the same model, by different ways. So I could switch to our application. I have opened it right here. So when we start from scratch, I select connection and start as maybe as a beginner from really basic screen and from the blank project. Yeah, so if I select the correct geometry and the blank connection, I just edit my materials if I need to, select the default bolts, but as mentioned before, everything is editable in the future. So just create project, and I can try to show you how it could be built manually. It means plate by plate, weld by weld, and in very maybe let's say stupid way, but it would be the way how I would process in the situation in case of very complex or very atypical connection. So it's not this case, but just as an example. So what I need first is some end plate to be welded to member B or to our beam. So I go through operations and select a stiffening plate. That's my basic element or basic component I will use. So the origin, I can change it to a member, and it would look like a doubler for the column. So not rib, but a doubler plate. and bottom flange is right, but from the other side, so rear, and it wouldn't be welded to a column, but welded to a beam. It's okay, and just dimensions. So as a basic, I can see 50, 150, 100, 200. So I can see in graphic scene what dimension I'm editing right now. So I know it would be something like this, and thickness 10 millimeters is okay for me, and I have my end plate. Now I just need to cut the beam member, and it can be done like a cut alongside the plate or alongside some work plane. So I can switch to work plane, and rotation would be 90, and I just need to move it to correct position. So if I see this one is HEA 200 plus 10 millimeters, so the position could be 105 millimeters. It's there, and now the cut. It's the first operation here, and cut by work plane. So now my beam is cut right where I need it. Okay, what about bolts? So it could be prepared by a bolt grid operation. My steel grade and the size 16 could work well. Okay, so what should be bolted to what? SP1 plate is correct, but it would be welded to the column flange. So it's the bottom flange, and I can see the position. So for me, the information is that 50 millimeters is the direction from top to down. So I just edit it to something like maybe this one. Okay, it's too much, 60 and maybe plus 80. Oh, maybe less. Okay, like this. And the other way also. Okay, I know what I'm missing. So I can use this separator and use 50 minus 60. Yes. That's it. Okay, and the other direction. So maybe like 50 and minus 50. Yeah, could be. Okay, I have my bolt grid there, and what's left is some stiffeners inside the column cross section. So I have two options here. I can go through this stiffener operation or make it manually. So just as an example, again, stiffening plate, it would be again in member C, but now it really is a rip, and the rip of the web. So all the dimensions, this would be something smaller. 150 could be like this, and this is 0. So back to solid view, I can see it's here, and it's right in the node. So I need to move it, yeah, into position of top flange of the beam. And now I could add some welds to the sides of the stiffener. So like this, it would be different edge, SP2, H4, and C top flange. Is it there? Yeah, it is. So it's new weld added here, and just by copying, I can move it to a bottom flange, but different edge of the plate. SP2, yeah, the edge number is 2. Okay, so that's the first stiffener here, and by copying I would bring all of them here, so it's another 1, 2, 3, yeah, another 9 operations. Or if I switch it off, the difference would be like this. So automatically by operation stiffeners, I can see all the necessary plates here put there automatically. Okay, and what's left is load effects. So I can see no loadings here. So maybe, for example, -20 and 10, just the shear force and some bending moment. And we can calculate and check if the model works or not. Okay, we have a singularity here, and what's the reason? So I can see that the calculation is unnecessary, even quick, but yeah, my beam is moved somewhere. So I can see that in the deformed view, something's missing. And what's missing are the welds on the beam and the end plate. So that's my way how to check it very quickly, what could happen, what could be wrong. And I just add these welds. So again, weld operation, and now it would be the whole beam B to the plate SP1. And now I can see all the welds are there, and now the calculation could be successful. And also, if I need to have different weld sizes on web and the flanges, then I would need to replicate this weld and make a single weld for each part. So not now, it's okay for me like this. Now I can see all the iterations quite quickly and everything's okay. And just the brief view into the check. So equivalent stresses on the beam, everything's there. And also, as I mentioned before, some bolt forces here. So in graphic view, I can see which bolt force is the biggest one and what's the course of these forces. Also in this part, in this chart, I can go bolt by bolt and take a look very comprehensively how the design code check looks like right now. Okay, so this would be the basic way how to model this kind of connection, but we have more smart solution for this task. So with the new connection, I can select the same but blank connection, create, and how to make it in a more quicker way. One way is to use our right mouse button. So just right click on the beam I want to connect to other member and use this connect to feature. What it should be, so it's quite obvious, it will be the column, and I have all the proposes for this type of connection. So if I want to make something similar to previous connections, probably this one would be my choice. Okay, yeah, type of or size of the bolts here. Yes, I'm quite there, and everything I need to do is just check if the sizes are according my expectations or not, and check the forces. So again, we could make it slightly bigger, so maybe 50 in shear force. What about 20 in bending moment? Okay, does it still work? Yes, it does. Okay, it's there. So this would be quicker way, and maybe the most popular way, or the way we would need in the most situations, is to use our wizard. So this window, as mentioned before, is our template wizard. So I can try to find my connection directly here. So this choice could solve everything just in the beginning of my workflow, and probably I wouldn't need to do much work then. Maybe some polishing or editing of dimensions, maybe change of some bolt sizes and so on. So this could be the presentation for our simple connection, and I would use the first model to show you what I meant speaking of the correct order of operations. So for this weld 3, I have welded member B to SP1. But if I would like to change it to something what will be added in future, so for example another stiffening plate, maybe some rip into the beam, so on member B, okay, where it is, position maybe 20, okay, related to plate, I can see it here. So now if I would like to weld this part to beam, for example, probably this option can't be here because it was added in future. So my plate named stiff 2B is in this drop-down menu. So that's the reason why the correct order is so important for modeling. Okay, and now I would like to jump back to our presentation and take a look on how to design more complex ones. So in advanced modeling, I would mention some tips for saving some time during the modeling process, and also take a look on some features of our connection browser tool. As an example or a use case, I would use this connection. It's not really so complex, but definitely more complex than the previous one. So 7 members, 2 beams connected to 1 column, and another 4 bracing diagonals going into the same joint. Everything's bolted, and we can show how much work can be saved, because we could see that maybe 10 operations were needed in manual creating the previous model with much simpler arrangement. But for this one, we try to do it in 7 operations, everything together. So jump directly into the app and how it be processed. So again, if we go from scratch through this initial window, we create another connection, and my goal is to select something so similar that the rest of the work would be quite piece of cake. So the most closest template I could find here is probably this one, and I know that I will use quite small cross section, so maybe the default bolt size could be M12, and that's it. So create project, and I can see that in my template selected here more members is present, so I can just simply delete some unnecessary ones. Yes, so maybe B4 and B3 could be deleted, so very simply like this. And also my goal is to make some corner connection, so I just rotate B2 to different angle, and the same for D4, D2. Yes, yeah, I would like to have the order, so why not? D1 could be 0, and my specific angle D2 would be 90. and again specific angle, so just below, sorry, 0. Yes, D2 under D1, D3 will be here, yes, and D4 under D3. That's better. This could be the basic arrangement for me, and just editing of the cross sections. So HEA 160 is my goal, so I can just switch for all these members to 160, and these are too big for me, so I can create a new new cross section, IP 200. Okay, and then the same for this one. Great. And if I remember correctly, in my example, I would like to use a circular cross section for bracing members. So I just change this one to a circle. Yes, something smaller like this. Okay, and now I just select in drop-down menu the same for all the others. Okay, so I mentioned right click or right mouse button click and creating a connection, so I can use it also here. So connect to a column, and what I could use is maybe this simple end plate, which I will edit in the future. Yeah, okay, so I just wanted to have slightly higher on both sides. Yes, and maybe another row of bolts. It's to profile symmetrical, it's correct, and I can move the bolts slightly from the web. So I just widen the plate and move it like it. Yes, that's better. And I would like to connect this diagonal bracings not only to B1 but also to this end plate. So I will use operation called connecting plate. Okay, so it's on the member D1 and connected to new plate, it's okay, but it's also related to this member, it's fine, and also to the plate. So which one it will be? Yes, it will be EP1, that's fine. And okay, there can be some required members. So sorry, it's not column, it's B1. Yeah, that's why. Okay, so some additional editing will be needed here. So the width can be smaller, depth higher, position definitely bigger. Yeah, cap plate. Yeah, cap plate like means it's only one tongue plate here. I would like to have two of them. So now it's better, it's from both sides and definitely narrow. Okay, and the bolt position is incorrect, so I can make it like this. Yes, two of them, and some minor editing of the geometry. So I can just right click on the plate I want to edit and make some chamfers on it. So value 15, and I can select or write which corners should be affected. So if I check here, apply, and I can see directly in the scene it's applied correctly. And the same for the gusset plate. So editor here, yeah, I can see the plate is too big, so maybe like this. It's enough for me right now. And also this editor is present here. So the gusset and some bevels would be applied. So for corner 2, like this, and copy to another corner. Yes. Again, I can check directly. Apply. Yeah, it looks good. And I don't want to make it manually on the other bracings. Yeah, maybe this cap plate could be also rounded. It would look better. So cap plate shape, circle. Yeah, that's better. And now I just can copy the whole prepared operation for another diagonal. So just switch to D2 and it's there. So perfect. And yeah, I can see that my stiffeners were prepared or built automatically, but on both sides. And I want them just on this front side, so not both, but the location would be front. And yeah, they disappeared from the other side. Now I could simply copy this to member D3, but it's a different situation here. I don't have this end plate, so it wouldn't be related also to, so this cross option, and it's not related to B1, but B2. And yeah, I have to mirror the geometry and probably move it slightly. Okay, and again, just right click editor. I just switch the order of bevels. So it would be 50, 70 here. Maybe like this. Okay. Yes, I know why. Yes, mirrored. Apply. Okay. That's it. Another copy operation for this D4. It's there. And somehow connect B2 to column. So again, connect to column, and I would like to use some cleat operation. So what about this one? This could be and different angle shape. So uneven shape, maybe 150. Okay, fine. Yeah, it's there. Perfect. And what's next? No stiffener needed there. And I would like to have it on both sides of the beam, so profile conversely. Okay. And probably, yes, member B2, connected to, okay. That's better. And now I would like to change the bolt grids there, and we can prepare different bolt grids to every side of this angle. And so just not same on both legs, but different. Okay, so the first one is here. It's okay, but maybe like this. Yeah, this could work, but just want to move it. Yes, that's better. And the other side, we can make more of them. So maybe 20, 60, minus 20, minus 60. Yes, and the position in this direction. Yeah, that's it. Okay. It looks like the model is prepared for some loading. Maybe we could make it lead length slightly smaller, like this. Okay. And what's needed is load effects. But right now we can show that in case of diagonal bracings, the model type, when I see that it's a obviously hinged connection, should be set for NVV. So I make it right now. And the loads in equilibrium can be turned on. So what has changed in my set of load effects, another rows were added, so I can make a loading for end and beginning of the column member, and I would like to import some forces here, so I can use XLS import to replace existing loading. And I have prepared some Excel spreadsheet for this import, so I just copy all these forces here, and the model is loaded automatically. Now I can see that I have some unbalanced forces here, and the reason for it is that I didn't edit the position of forces on the beam members. So here, if I switch back, I would edit the position of forces on member B1 to some specific position, and I would move it on the edge of the column. So the edge is 76 millimeters, and I can check it in wireframe display. Okay, I can see it's exactly where I want it to have it. And for B2, because it's this type of connection, I can select position in bolts. So again, as a check, I can go to loadings and B2. Yeah, the zero value of bending moment is directly in the middle of the bolt grid, so it's correct, and I can calculate the model. And because quite a lot of members is here, so I have already prepared the calculated model for you, and it looks like this. So everything's gray or green. It looks like good design, and we can check all the necessary results here. So maybe some plastic strain could be interesting. We can see whether some plastic is here or not. So only this column web. So maybe some doubler could be added here, but it looks quite well. Okay, and that could be maybe enough for this part of presentation. And one tip for you, as we mentioned, the option of using the previous connection for another design code. I could use my design in this model for another project, maybe from different region, different location. So if I switch off some parts, maybe this D4, D3, B2, and all related operations, then okay, click again, then I can use this part of the connection for future projects. So what I need to do is use this publish button and select what type of set of my templates I would like to use. So I just select private and name the connection, name the template, click publish, and what I will find in this manage part is my set of private connections, so I can see it here, and now I can use it in different project. So I have something prepared here. So this is similar project, but prepared according to AISC design code with US cross sections. So really different project file. It's opened. Yes, right here. Okay, so right now it's empty, no operations are there. It's a different geometry, different cross sections. We can see it's a US cross section here, and we can try to propose something for it. The first option is quite empty, but I can select just a part of the connection, so like this, and confirm by enter or spacebar, and I can see that my previously saved template is here, and I can just apply it. So select correct size of the bolts, and yes, it's there. So this way I could very simply design something in future. So maybe the same one for the other side. 1, 2, 3, 4. Yeah, confirm, apply, maybe different bolts. Yes, it's there. So we can see here it's AISC design code, and the same work already done before can be reused once more. And the third part of our presentation would be the BIM-link with some CAD application. So it's the situation when I have already prepared some CAD model with all the detailing work already done, and we can show how to import such a connection and how to finalize or polish this model. So it's very similar, maybe the same connection. So I just open my StatiCa model. It should be right here. As you can see, very simple simple structure and one prepared connection in here. And what I have already prepared is I have my IDEA StatiCa plugin in here. Simply click on checkbot, which is our manager for BIM links with third-party applications. It's opening on the other screen, and it will prepare my structural model for me, and I can import connections. So create project, bulk selection, and just like this, one question, whether I want or don't want to add also recommended welds. So for now, it's a no. And in the connection app, I will see what was brought here. Okay, some things here, and that's exactly the part of structure I'm interested in. So I can see again my 1, 2, 3, 7 members here and one connection in between. So after opening this connection, I should see exactly the same detailing work as in StatiCa structures. So just a few seconds for opening the connection. Yes. Okay. Still working. Okay, it's here. Perfect. So what we can see here, it's the same connection, and we could just simply load it and calculate again. And from these CAD applications, for example, Advanced Steel, Revit, or StatiCa structures, sometimes some information could be missing. Some information as a weld type can be different from what we expected. So very simply, we can fix it in our connection model, and it would be correct very quickly. Perfect. And yeah, from this part, I could go to my summary of this presentation, because it maybe took a little longer. So what we showed here, for simple connections, probably our template wizard or operation templates would be the best choice, because it's very often enough to use the template, edit something, and then maybe add some simple plate, some simple operation, and you're good to go. But with some more complex ones, definitely if you use the special connections and you use it quite often, then the work with connection browser could be better choice, because you can save a lot of time in future. So maybe more time in the beginning with preparation of your own private set of templates, but it can save you some time in future. And in case you also have your CAD model with all the detailings, then probably checkbot is the smartest way. It's the quickest way how to bring your analysis model to life and just check all the details necessary. And that could be probably end of my part here. And I would like to change the presenter and put the word again back to Adam. Adam, are you here?
Yes.
Perfect.
I'll just switch. And there we are, right? Oh no.
Yes, I can see it.
Right, let's switch to this screen. Right, now you should see the presentation, right?
Yes, it's there.
So we're jumping just right to the second poll that we have prepared for today, and that is, I'm just launching it now. So the question is, you've seen the connection browser that was demonstrated by Jan. Question is, have you ever used it? Have you tried how it works? Open it, did whatever can. So there are just three possibilities. No, and I am not interested, I will not use it. Second one, no, but it looks nice and I will try it. And the third option is yes, I'm already using it. All right, so a couple of more seconds. I can see again more than 80% of people have already voted. So let's give it a 5 more seconds and close this poll right now and see about the results. All right, so you can see bigger half of you haven't seen it before probably, but likes it as it looks. We'll give it a try. That's great to hear. And smaller half is already using it, which is a pleasure for us to hear because it's quite a new feature. So thank you for this poll, and I'm going to hide it and conclude this presentation and this webinar. So we've got two questions and answers sections. So I'll probably give presenter back to Jan and take a look, pick some of the questions that you send us. There was a couple of questions about measuring in IDEA. Is there any measuring tool in the 3D model? So there is, and I can answer this.
Okay, I think you should know it
not,
too, so you can.
There are some options, right?
Yes, exactly.
So if you can maybe quickly demonstrate that.
I can show you what I like most for measuring. So it's not possible directly in the graphic screen, but in this editor, as I showed before, there is also an option of drawing. So maybe the quickest way how to measure something, some part of the connection, is this for me. You can see, yes, all these dimensions of holes and the distances of the holes and the dimensions of plate, and it could be very useful. And also you can somehow export into DXF or a bitmap format this one. So that's one way, and maybe you will mention some other ways how to do it quickly.
Maybe also if you click in the 3D model or select some operation, it shows you, for example, select the end plate. It shows you the dimensions in the 3D window
Yes.
as well, the basic ones, yes.
Mm-hmm.
And
Yes,
what
correct.
comes to my mind, the third option, maybe if you right click on the end plate and create a section, then
Yes.
it also provides you the dimensions and also some simple sketch or drawings that can be printed out into report.
Exactly.
Well.
Maybe one more option is to send the project file into the Cloud Viewer app, and then you can simply export the 3D DWG format. So then you can measure everything, but it's probably not the quickest way, but it's another option how to measure.
Okay, thank you for that. And I'll leave the presenter to you for one more minute. There was another question about report from Mr. Kushal. Can we have a detailed report, and how can we organize the report? So if you can just briefly show how it looks.
Okay, so maybe really quickly, yeah, we have different types of reports possible here. So in this part, you can see brief, one-page, detail, or bill of material. So according to what you need for this case, probably the detail one would be the best option. And in this right side of the screen, you can select which part you're interested in. So you can switch on and switch off the specific part. And this part is also very important. Then in the specific parts, you can select also what everything should be there. So these are options for importing pictures. So if you export something into gallery, for example, or you have some user-defined sections, as I showed just previously, it can be added there. Some results, so different options. You can add a bill of material with or without pictures, and so on and so on. So you could get quite comprehensive report with tens of pages, and not only for the specific current model in one project, but if you have several models here, as I have right now, you can pick these options and select which one should be involved in report and which one not. So probably this could be a very brief overview of detail report.
Thank you very much. So it's all editable. And maybe last question that will be more like a demonstration. We got a lot of let's say small questions that can be the answers can be found in the support center. One was, for example, what is a singularity? So maybe if you can demonstrate and show our attendees how to get to support center. If you go to webpage ideastatica.com.
Okay, can you still see my screen?
Yes, yes, I do.
Okay,
so this is the
web page, and just in the middle is a support and learning and support center. So this window is the most important for you. You just need to select correct keyword for it. So
Yes.
if you're
So if you
interested,
type singularity, for example, let's
for
try.
example, yes. So here, knowledge base is the first answer. So what is the singularity warning? And you will find some information to it, some videos, and much more information. So maybe 5 of these results could be useful for you. So feel free and don't be afraid to use this tool, this search window, because it can save a lot of time for you.
Yes. Okay. Thank you very much, Jan. I think we covered most of it and we're running out of time, so I'll just jump back to the presentation, and so I'll take back the presenter. Just a second. All right. Yeah. So I just want to conclude this. After webinar, you will be asked to fill out a very short survey. Please do if you can. A recording of this webinar, also a couple of questions we got for this. This will be available today on the web page in the section that Janko just showed you in the support and learning. You can find this webinar page and the recording there, and in our YouTube channel, IDEA StatiCa. So it will be there, available for free for anybody, all the time, forever, hopefully. Then for the newcomers to our webinar, if you got interested, feel free to get the free trial version in our webpage. It has full functionality and it lasts for 2 weeks. So you can try this software for free as you like. And Support Center, of course, library of knowledge that we have already mentioned. That's available on our webpage, of course, for free for all of you. All right. Next webinars that are ahead of us in April, this will be a release webinar. We are releasing new version of IDEA StatiCa 22. So we'll be discussing new features, new improvements there. So hopefully we'll make some of you happy. And in May, there will be a webinar covering some interesting topic for our concrete applications like detail, RCS, beam, etc. So that's it. Thank you very much for attending today's webinar. Hope you liked it, and I'm looking forward to see you next time.
Okay, thank you very much too for your attendance, and take care and stay safe.
Bye-bye.
Bye.